Hello, this is Mehmet Okay. Today, I will present to you the paper titled Examination of the Difference Between Laboratory Measurements and Calculations Results in Impacts on the Installation, which is kind of a summary of my master's thesis. In the first part, answers to the following questions were sought. Why is acoustic comfort important? What are the sources of structural noise? What is the impact sound level and impact sound insulation level? In the second part, the following topics are examined. How to calculate impact sound level? Is floating floor application necessary and why? What is the usage area of floating floor? In the third chapter, the following topics related to impact sound insulation are examined. How to calculate impact sound insulation level? Which parameters affect impact sound insulation? Why is there a difference between calculations and laboratory measurements? In the conclusion section, the findings are discussed and recommendations are developed. As you know, we have expectations from today's architectural structures such as being economical, safe, aesthetic, functional, and providing physical comfort conditions. Physical comfort conditions can be explained as thermal comfort, visual comfort, and acoustic comfort. Noise control and volume acoustic studies are carried out as the subtitle of acoustic comfort. Due to city life and living in high-rise buildings, we are exposed to many noise sources in our homes and workplaces. Each of these noise sources negatively affect our lives due to their psychological and physiological effects on people. However, due to the differentiation of the solution method, impact sound insulation is considered to be of particular importance. The sound heard on a lower floor due to the impact on the floor is called impact sound. An elastic material should be used between floor covering and floor in order to reduce the impact sound on the lower floor by reducing the impact on the floor. Impact sound level difference between sections with and without elastic material is expressed as impact sound insulation. Since these solutions should be applied in principle for impact sound insulation, eliminating the discomfort caused by incorrect application, wrong calculation, or wrong material selection causes very significant time and cost losses. For this reason, the right solution of impact sound insulation at the design stage is crucial. Impact sound level calculations are made in the 1/3 octave band in the range of 50 and 5000 Hz, according to EN ISO 12354 Part 2 standard. As can be seen from the figure, the sound generated on the lower floor by the vibration of the floor body due to the impact is called direct transmission. The noise generated by the transmission of the vibration in the floor to the receiving room through the walls connected to floor is expressed in direct transmission. Direct and indirect transmissions are summed on a logarithmic basis for the total impact sound level generated in the receiving room. After the volume effect is included in the calculation, it is weighting according to EN ISO 717 Part 2 standard and turned into an odd number. In order to understand in which situations a floating floor is necessary, a theoretical model living space has been established, as seen in the figure, according to the most unfavorable combination and structural element situations. The theoretical model living space was chosen as a room located in the corner of a building and on the mezzanine. This is the plan view of theoretical model living space. In this theoretical model living space, only the floor thickness was changed between 15 and 40 centimeters, and impact sound level calculations were made by keeping all the variables constant. The calculation results and the highest allowable impact sound levels, according to Turkish standards, are compared on the chart. According to the chart, impact sound insulation evaluation is required for all reinforced concrete floors with a thickness between 15 centimeters and 14 centimeters. The arithmetic difference between the two graphs reveals the impact sound reduction that the floor covering must provide. The table shows the impact sound reduction required to achieve acoustic comfort according to the noise level and the targeted acoustic performance classes. As seen in the figure, impact sound insulation can be made under floor coverings such as parquet and ceramic, as well as under squared with floating floor application. The results of 48 impact sound insulation laboratory measurements made according to EN ISO 10140 Part 3 standard of materials with different thickness and surface shapes belonging to different manufacturers from different countries were examined. According to this examination, it was seen that delta LW 19 decibel is the transition zone. In general, impact sound reduction of up to 19 decibel can be achieved by insulating the impact sound under the floor covering, while it has been observed that impact sound reduction can be achieved from 19 decibels to 37 decibels with the floating floor application. For this reason, the table has been arranged as it is in order to understand the necessity and usage area of loading floor. As can be seen from the table, floating floor have a very wide usage area. Impact sound insulation calculations for floating floor are made according to EN ISO 12354 Part 2 standard with shared equations. As can be seen from the equations, the impact sound insulation according to the calculation method depends on the mass per unit area of the floating floor and the dynamic stiffness of elastic material. However, studies show that there are differences between laboratory measurements and calculations. In this part of the study, the factors causing the difference were examined. Firstly, dynamic stiffness. Dynamic stiffness is measured in the laboratory according to EN 29052 Part 1 using a steel plate measuring 20 centimeters times 20 centimeters and weighing 8 kilograms. Assuming that this measured dynamic stiffness is constant in all cases, impact sound insulation calculations are made. However, in the study, the results of which are shared in the table, dynamic stiffness were obtained from laboratory measurements of impact sound insulation by reverse engineering with the relevant equations. According to the table, two conclusions are drawn. One, measured dynamic stiffness and obtained dynamic stiffness are different. Second conclusion is dynamic stiffness varies depending on the mass per unit area of the floating floor. Secondly, creep deflection. It is well known that the impact sound insulation materials are subject to creep deflection due to the constant pressure on it. This study, whose results are shared, reveals the change in dynamic stiffness of the material due to time-dependent compressive creep. Thirdly, dimensions of floating floor. The results obtained with the current calculation model according to EN ISO 12354 Part 2 standard is obtained independently of the dimensions of the floating floor. However, the study whose results were shared shows that the variation of dimensions of the floating floor affects impact sound insulation performance. Finally, damping ratio. In the calculations, the damping ratio of the elastic materials is not taken into account. However, The transmissibility model used in vibration isolation reveals the effect of damping ratio. In the graph, the huge difference between the current model and transmissibility, especially in the resonance frequency, is theoretically demonstrated. The graph shows the difference between the calculations made with the current model for a material and the measurement made in the laboratory according to EN ISO 10140 Part 3 standard. The effect of damping ratio can also be observed in this experimental study clearly. Conclusions. Impact sound is one of the important structural noise sources which affect people. For almost all cases, impact sound insulation is needed to be considered. Because its principal solution method, impact sound insulation are being done under screed or under floor covering. That's why reconstruction is needed to fix acoustical discomfort caused by wrong application, wrong material, or wrong design. Because of reconstruction, living area cannot be available for relatively long time and unforeseen costs will arise. For many cases, floating floor applications are needed. There are differences between laboratory measurements and calculations for floating floor applications. The parameters which affect impact sound insulation performance of floating floor are dynamic stiffness, dimensions of floating floor, and damping ratio of elastic material. Because it varies with mass, dynamic stiffness can be measured with 20 centimeters times 20 centimeters steel plates of 4 kilogram, 6 kilogram, and 10 kilogram in addition to 8 kilogram. Because of creep deflection effect, dynamic stiffness can be measured 21 days after the system has been prepared. Impact sound insulation performance can be measured 21 days after the system has been prepared also. Because of its crucial effect, a new calculation model which includes dimension of floating floor and damping ratio of elastic material can be studied. Thank you for listening. Have a good day.